Welcome to trig circle part 2. In the first trig circle part 1, we talked about degrees and sine and cosine and what they meant on the trig circle. So today we're going to talk about radians and what are radians. So radians are a unit of measure, just like degrees, but it works a little differently. You're going to see notation like pi over 6, pi over 4, like the ones you see in front of you. Well, I'll explain in the next screen what each of those mean. Before we get to that, let's just look at two different versions of how you could see pi. So pi on a circle represents, if you remember, if this is your circle and this is your 0, it looks like an egg, I'm sorry, and this is your pi, and that's the other end of it. Well, 0 pi, and it's, if you look at your protractor, this other side is 180 degrees. The entire circle is 360 degrees. So by definition, pi represents 180 degrees. But we also know that pi represents 3.14 and a bunch of other numbers that I shall not put at the moment. So if you were to write something like pi over 2, well, that simply means 180 degrees divided by 2, which represents 90 degrees. Of course, if you're talking about pi over 2 representing 3.14, then 3.14 divided by 2 equals to 1.57. So it is two different ways of looking at the same concept. So you can say, well, okay, that means, oops, I was not looking for that color. So you can say, well, at that red space, we can call this over here 1.57, or we can just say it's pi over 2. It's so much prettier to write pi over 2, but do recognize that sometimes you will have decimals. So if this is 1.57, obviously this is going to be 3.14 or pi, and of course this is 6.28 or 2 pi. So that's basically the difference between representing it in a fraction like this or representing with decimals. Now, the pi over 2, the pi over 3, the pi over 6 are the common fractions you're going to be seeing. You're only going to be seeing over 3 over 4, over 6, and these are the ones you kind of have to memorize, and over 2, because they're the ones that are easiest to work with. Now, if it's not these numbers, you're going to have, like, it's rare that you're going to see something like pi over 5. It may happen, but you don't often see it. You could obviously figure what that is, 180 divided by 5. So just to be on the, have your memorization stuff down packed, you should know pi over 2 is 90 degrees. Of course, pi is equal to 180. That's your basic. And then pi over 4 is 45 degrees, pi over 3 is 60 degrees, and pi over 6 is equal to 30 degrees. And of course, the 2 pi is equal to 360. Now, there are times you're going to see things that look like this, and I'll explain this further down. 11 pi over 6. Well, what does that mean? Well, technically, it means 11 times 180 divided by 6. So it's the same idea of going around and around in a circle, like going to, 720 degrees, 750 or 900 and something, or 1,000 and something. So 11 times 180 divided by 6 is going to give you 330 degrees. Now, clearly on a circle, you have an idea where that is. I mean, if you make your circle and you know that 360 is somewhere here because you started off here and went all around, let's not forget we have to go counterclockwise. Well, if 360 is there, that means 330 must be somewhere around here. So if you would look at your entire circle, and I highlighted that area, the 330 would be all of this section right here. So that's how it works when you're dealing with pi's and radians. Now let's explore exactly what radian measure means. And I have a picture of a circle right here. So just very quickly, a radian measure represents typically the radius. So if this was a string and I was able to bend my radius into a string, I would be able to take this radius, the size of it in fact, and literally place it on half my circle. And like, let's say this was like the first place that, excuse my drawing, but if I bent my string and then I took, that was the first string, then I took this again and I put it up against the rest of the circle and it kind of landed here. And then I took the string again and I laid up against the rest of the circle. And then I stopped right here. So up until here, I used, supposedly, 3 radiuses, or 3 radii. That's what it's called. I think it's spelled like this, radii, something like that. And then there's a little bit left over. Now, if you think about that, little bit left over represents that 3.14. So basically 0.14 something of a string or of the radius. And then, of course, if you continued, you do 3 more strings. So 1, 2, 3, and then something left over. That something left over was the other 3.14, and of course that altogether makes 6.28. So that's where the idea of 2 pi comes from and where pi comes from. Okay, so moving along. Now, how do we divide our circles so that we understand what all these pi business means? First, we're going to divide our circle into the fraction of pi over 2. You're going to see things like pi over 2, 3 pi over 2, 7 pi over 2. We're going to locate where all these pi over 2's are on the unit circle. So the first rule of thumb is you look at your denominator. If your denominator says 2, you're going to divide your half circle, only your half circle, into 2 parts. If your denominator says 3, then you're going to divide your half circle into 3 parts. We'll do that next. For now, let's divide our half circle. So our half circle is the top part, and then there's the bottom part. So there's 0, and then there's pi on this side. So 0 and pi, our circle is already cut into 2 parts, 1 and 2, 3 and 4. So that means 0, and then this would be your pi. Oops, what's going on here? All right, sorry about that. So pi over 2. And if that's pi over 2, then you're going to go here. And you're going to say, well, this is then 2 pi over 2. Now, 2 pi over 2. But we know that if we reduce 2 over 2, it becomes 1. And that is why it's pi. But we're going to continue to label it in this fashion. So this would be 3 pi over 2. This would be 4 pi over 2. Of course, if you reduce that, that becomes 2 pi. Now you're going to continue if you want to, just like you do when you're adding degrees. So this would be 5 pi over 2. If you come back, this now becomes 6 pi over 2. This still, what did I write? 4 pi over 2, 5 pi over 2, 6 pi over 2. This becomes 3 pi. There we go. And down here, this becomes 7 pi over 2. And then again, if you continue, this becomes 8 pi over 2, which reduces to 4 pi. Now, what do you notice? The things on the left and the things on the right. Now, let's look at the left. This is 1 pi, 3 pi. These are odd numbers. So always on the left-hand side, you're going to have the odd. On the right-hand side, you've got 2 pi and 4 pi. So on the right of your circle, you're always going to have your even numbers. Now, this is important for later on for locating points. So that's basically how you do the pi over 2's. In the next circle, we're going to work with pi over 3. Okay, so pi over 3 means you're going to divide your half circle, that's the top part, into 3 parts, just like your denominator. So when you look at it, you have your 0, you have your pi. Yes, we get that. But it's kind of like thinking of slices of pizza and you want 3 equal parts. So what you want to do is you want to cut it into, remembering that actually this is 60 degrees, right? So think about where 60 degrees would be. because 180 divided by 3. So 60 degrees would probably be around here. And then if you take it from here, it's going to be in the same spot. Something like that. So now I have 3 pieces. If you look at our 3 pieces, I'm going to highlight them. You've got this one here in the middle. Kind of looks like McDonald's colors, but hey, it's okay. And then you've got this one here. And then you've got the other one. Now, I didn't put the red lines on the horizontals, but you're going to definitely count that as part of your pieces, because if you're going to continue this separation of your half circle in the bottom, you're going to also have 3 more pieces, right? So basically, it's like stretching this all the way across and stretching this all the way across. Then you have your 3 pieces again. So on the bottom, again, you can highlight them or not. It doesn't really matter, but you have your 3 pieces in both sections. So at this point, we're going to now we're going to now label our pi over 3. So this one is going to be pi over 3. There's nothing here because this is part of the piece. This one is 2 pi over 3. Now down here, it's actually 3 pi over 3. And yes, we know that that reduces to pi. This one is 4 pi over 3. And this is 5 pi over 3. And then this becomes 6 pi over 3, which reduces to 2 pi. Of course, you could continue 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi, 11 pi, 12 pi, 14 pi, all over 3s. You continue over and over and over again. Now we're going to move on to the next circle. We're going to do now pi over 4. The pi over 4 literally is like the pi over 2, but you're separating into 4 parts. So again, this is 45 degrees. You're going to take your half circle and you're going to divide it into the denominator. 4 parts. So I'm going to just literally go here and do this and this. That's not 4 parts. Oh, yes, it is, because I'm counting the one in the middle. There we go. So and let's not forget the horizontal. So we have the 1, 2, 3, 4, 4 parts on top, 1, 2, 3, 4, 4 parts on the bottom. Now let's label, and some of them are going to get reduced, so don't worry. 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Now look at the circle and think of which ones you can reduce. So this one, no. This one, absolutely. This one, no. Can you reduce this? Absolutely. Pi. This, no. This, yes. This, no. So technically, and if you were to go to 8 pi over 4, well, that reduces to 2 pi. So technically, you only have to know 4 of them, and those are the ones in each quadrant. Quadrant 1, which is over here, quadrant 2, quadrant 3, and quadrant 4. So you only know that pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The rest just help you figure out where things are. Then, let's do the pi over 6. So of course, with pi over 6, you're going to divide your half circle into 6 parts. So by dividing your half circle into 6 parts, you end up having something that looks like this. Well, you've got the 30 degrees, then you've got the 60 degrees, and then you've got the 60 degrees here, and then 30 degrees there. And then, of course, that's 1, 2, 3, 4, 5, 6. And then you're going to have your 30 degrees here, your 60 degrees there, They might not be very even, but that's how I'm trying to explain it here. All right, so if you notice pi over 6, if you remember, that would be 180 over 6, which makes 30 degrees. So let's look at this. This is your 30 degrees, also known as pi over 6. This is starting off at 0. That means that this one is going to be 2 pi over 6. This is 3 pi over 6, and this would be 4 pi over 6. This is 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Now the true over 6s are this one, this one, this one, this one, and this one. So there are really only 4 because the rest are all reduced, right? They're pi over 3, pi over 2, 2 pi over 3, and pi. And this one is 3 pi over 2. No. Divide by 2, so it's 4 pi over 3. And this one would be 3 pi over 2. And then this one would be 5 pi over 3. This one's legit 11 pi over 6. Okay, and of course, if you go to 12 pi over 6, that makes 2 pi. There you go, you have your even number again. So the only ones you have to memorize are those. But instead of memorizing, it's important to understand. Now we're going to go into how could you figure out where 5 pi over 6 is without sitting around and doing this round and round the circle. So let's look at that. So supposing I ask you, in which quadrant is 5 pi over 6? Well, here's a very easy way of doing it. First, let's make something we do know. We could write 6 pi over 6, I know happens to be on this side because it has to be an odd number. So if this is 6 pi over 6 and I want to go to 5 pi over 6, which direction do I add and which direction do I subtract? So if you remember from the first video, in this direction I subtract, in this direction I add. So if I want to go to 5, it's 6 minus 1, and it would be 5 pi over 6, which brings me in quadrant 2. So that's how basically you can figure that out. So if I said, where is 13 pi over 6? 13 pi over 6. Well, I know that 12 pi over 6 is going to be here. It's an even number. And if I'm adding, then 13 pi over 6 must be 1 more. And that would be it. And that's how you go about doing that. Okay, so now let's look at really trying to figure out some, numbers that we have no idea what they're talking about. And you're trying to figure out where exactly is that on the circle. So supposing I gave you just this circle, and I told you I want you to locate, I'll make up some number. Locate 35 pi over 4. Not only do I tell you to locate, I want you to find the sign of 35 pi over 4. Okay, so how do you do that? First of all, we know we're talking about 4s, right? So I could sit there and divide my circle into 4 parts, just the way I did it. And I start calculating blah, blah, the way I was doing before. Very time consuming. What you could do instead is you can say, well, how many times does 4 go into 35? How many times does 4 go into 35? Instead of looking to say, well, it goes about 7 times because 7 times 4 is 24, I would say it goes, actually 8 times 4 is 32. What am I saying? So 8 times 2, it goes about 8 times. I would say, well, about 9 times. Because 9 times 4 gives you 36. So if I think about it, 9 is an odd number. Odd. So where would that be? The 9 would be here because odds are on the left. So that means this would have been 36 pi over 4. But I don't want 36 pi over 4. I want 1 less. So if you want 36 pi over 4, you must subtract a pi over 4. so that you can get to 35 pi over 4. So which way is subtraction? Subtraction is in this direction. So this is you subtract because it's going clockwise. And that would mean that this right here represents 35 pi over 4. And that's the location. Now let's look at what is the sign. Well, we know that pi over 4 has the same sign no matter where it is. It's just that the quadrants change. So the quadrants have the positive, negative, and the negative, positive, and so on and so forth. So this one negative, negative, and this would be positive, negative. So at quadrant 2, the sign is going to be positive because the sign represents y. So we've memorized it from video 1 that at pi over 4, the sign is equal to root 2 over 2. So your answer is positive root 2 over 2. And that's it. Let's do one more example. So I ask you to locate for me. I want to know the cosine of 39 pi over 4. Let's see if that one works. So what am I asking for? I'm asking for in the circle or on the circle, where is this going to be located? I just made this one up, so let's just see. How many times does 4 go into 39? 39 divided by 4 is about 9. But is there something left over? So what's the closest they could go to? 10 times. So 4 times 10 makes 40. So I would say about 10 times. Now, for it to be about 10 times, it must be 40 pi over 4. That makes 10. Now, 10 is an even number. That means even is on the right-hand side. So if this is 40 pi over 4, which makes 10 pi, and I need to go to 39, I need to subtract or do I need to add? So this way is addition, this way is subtraction. So that means I'm subtracting 1 and I'm going to be in this quadrant right here. And this is my 39 pi over 4. Now what is the cosine? Again, you have to memorize that the cosine and sine of pi over 4 is equal to root 2 over 2, that's for cosine, and root 2 over 2 again, that's for sine. All I asked for was the cosine. So you need to just look at what is the cosine. But in this quadrant, which is quadrant 4, cosine is the x component. And is it positive or is it negative? Well, in this quadrant, it's positive. So your answer is positive root 2 over 2. You don't have to write the positive. I'm just emphasizing on it. All right, and that's it for now. We'll practice some more. Hope that was helpful. And let's see how we can stop this now. Bye.